Hello, and thank you for joining us for today's webinar sponsored by EverAg. I'm Beth Holcomb, Vice President of Membership and Communications for ADPI. And before we get started, I'd like to touch on a few tips for today's webinar. Questions can be submitted anytime during today's presentation using the Q&A icon. Due to the depth of the content being presented today and the large number of participants, we do encourage you to identify yourself when submitting a question, as this will help our presenters connect with you for any follow-up after the live broadcast if your question is not addressed during the session. Access to recordings of ADPI hosted webinars is a benefit reserved exclusively for ADPI members. All ADPI hosted webinars can be accessed through the Dairy Use section of the ADPI website. It's now my pleasure to introduce you to our moderator for today, Andy Powers. Andy brings over 30 years of technical, commercial, and scientific experience to ADPI, where he is Vice President of Technical Services. Welcome, Andy.
Hi there, Beth. Thank you so much for the introduction, and I'm very happy to be back here in 2026, continuing what has been a very collaborative and useful partnership with EverAg to put on this series of events. As Beth mentioned, with question and answer, I'm here really to manage that part of the program at the end of the presentation today, and those questions can be submitted anonymously. We're also going to be enjoying some live polling exercises during today's webinar. I think we have 3 polling questions where I'm encouraging you to submit your honest responses at each step along the way. That will help our presenters to engage with you more effectively and to interact with you as they shift or adjust the content they'll present. I do want to encourage you to accept that we're not scraping any metadata, your contact details, or in some way enrolling you in automated marketing after the fact based on that polling participation. So just recognize that you're really free to engage and give truthful and thorough responses that will steer the rest of the webinar content. We really appreciate that. Let me get straight then into introductions for today's presenters from EverAg. First up, we have Michael Roberts, who is Senior Product Manager for the implant category. Michael is an experienced IT and product management professional, currently serving as Senior Product Manager with EverAg, where he specializes in developing and delivering innovative technology solutions that drive efficiency and business growth. Michael brings a strong technical foundation to his work, holding certifications as an AWS Certified Solutions Architect, a certified professional in the Open Group Architecture Framework 9.1, and in DevOps Foundations. His expertise spans strategic planning, project management, and operational optimization, enabling him to bridge the gap between technology and business objectives. And Michael today is joined by his colleague, Eric Swift, who is Operations Director for the dairy segment of EverAg's business. Eric is an experienced operations and agricultural technology leader, serving as Operations Director Dairy at EverAg, where he helps to drive operational excellence and strategic initiatives within that dairy segment. With a strong foundation in agricultural operations and a focus on delivering scalable solutions, Eric's work supports EverAg's mission to modernize and optimize agricultural processes through technology and data-driven decision-making. Eric brings industry insight and leadership to his role, working collaboratively to enhance efficiency and outcomes for dairy operations. We're lucky to have both of these experts here today, and Michael, you're going to take it away.
Awesome. Thanks, Andy. Thank you, Beth. So, yeah, today we're excited to talk about probably the biggest buzzword in technology around AI, but more specifically in the dairy industry and in an application we're calling production optimization or yield optimization. Through our lens, talking to current customers, potential customers, we've seen this application of AI be worth around an average of $5 million per facility per year. So certainly more ROI than a lot of the kind of ethereal AI projects or use cases that you see out there, which is great. So today we'll talk more about kind of the current AI moment in the dairy industry, build versus buy, which is kind of always on everybody's mind, and how some other use cases around AI kind of flip that decision, what it takes to actually manage a system you build, and then some of EverAg's approach and wins around production optimization. So before we jump kind of directly into the AI side of this, just for those of you that aren't familiar with EverAg, We are a global agricultural solution provider, focused mostly on providing software across the ag supply chain. And then we also have an insights division and risk management. Obviously, today we'll be focused on dairy, and Eric and I both work within the dairy side of the house, but we do software solutions for traditional ag and livestock as well. And then, yeah, just beyond kind of, small dairy shops, we are a software provider at scale. So, I think we provide solutions across 5 continents. We have over 2,000 customers, and you can see some of our other statistics at scale, but really, we have a lot of dairy customers, dairy processing customers, and we've talked with a lot of them about um, production optimization and at their scale, and we kind of just want to share our insights today with you. So I think that takes us to our first poll. So everybody's favorite thing, an interactive poll to start before we bore you. But really, we just want to get a sense of kind of, where is everybody in their organizations at in their AI journeys. So I'll give everybody about 30 seconds here. Feel free to answer. Obviously, this is all anonymously, so anonymous. So go ahead. I think that takes us pretty close to 30 seconds. Cool. So, um,
Nice even
well,
mix.
yeah, nice even mix all over the board. Certainly see understandable. We're waiting to see real results before we implement anything, starting in the process. So that's great. So then hopefully, our conversation today can help, help drive some realization in organizations around, what to do, or at least, where to start looking. And then just a second kind of follow-up poll, but kind of the follow-up question is, how is my organization thinking about implementing AI? So again, 30 seconds, and then we'll get started. All right. I think that takes us to about the time limit. All right.
Another nice even spread here.
Yeah, that's great. We don't have a monolith for an audience today. That's that's excellent. But I see highest scored there. We haven't decided yet. That makes total sense. So, um, that specifically, hopefully we can at least to provide some perspective at least around what it would look like to build something yourself as a part of this. So, um, jumping into, the current moment of AI and dairy, I think like every industry that's currently seeing a lot of AI adoption, or at least talking about a lot of AI adoption, dairy makes a ton of sense. It's a data-rich industry, and I'm sure you guys know this, but data is really the engine that drives the quality and the usability of AI. Without quality data or quality context of the data, your general application of any type of artificial intelligence is going to struggle because it's not going to be functioning in a way that mirrors what reality is, right? And so when we talk about data and dairy, obviously what used to be handwritten logs and notes, that's now digital make sheets, it's connected equipment, it's your inline sensoring, it's all your integrations that you've built with what used to be standalone systems as your ERPs, your your manufacturing information systems, your manufacturing execution systems, your lab systems. So, right now, I think in the last 20 years, the dairy industry has made a huge jump as far as producing and then better managing the data that comes out of the production process, which puts it kind of in a very good place to start adopting, or implementing types of artificial intelligence solutions, right? And and where that is going, or kind of what we're seeing, those types of solutions, or at least ones with, real ROI attached, is kind of into a more intelligent version of, the classic plan, do, check, act cycle, right? In the manufacturing space, this is kind of always driving a lot of your value add, or at least what you're looking at. And what we're seeing is, a lot of the adoption around artificial intelligence, or the subsections of it that really provide any type of real return on investment, are the ones that apply artificial intelligence, either one or many of the steps of that, plan, do, check, act cycle, and go from turning that into, what used to be, weekly, monthly, kind of experiments, test the data, understand, to then, real-time loops, right? Whether it's the recommendation based on what the machine learning models are seeing, or it's something around interpreting the results, but really applying to that loop is accelerated a lot of the performance improvement that we've seen, at least. And I know I've mentioned AI, and I when I'm talking about AI, and at least in the context of today, I'm kind of talking about two subsections, or two areas within artificial intelligence. The first one being machine learning, which is, kind of one of your more traditional um, areas of artificial intelligence. And I'm sure a lot of you guys have heard that. It was a pretty big push right in the early 2000s, 2010s. And the other half, or the other area that really what we're talking about today, are large language models, LLMs, and, the associated agents that are seen to be built off of those foundational models. So, yeah, when I say AI, I'm probably referring to one of those two areas today. And so, kind of that's the moment of AI and dairy, at least as we see it, right? As far as the high level, read a really interesting statistic off a survey that Cisco, the technology hardware company, put out. This is 97% of CEOs plan some type of AI integration into their company. And I'm sure if you guys have been listening to earnings reports, it's probably closer to 110% at this point. It's, I think, a word used more than the actual financial numbers themselves. But of the 97%, only 1.7% feel fully prepared. And I think that mirrors kind of the polling that we did earlier, right? We have a large swath of individuals. This kind of means that there's really no single directive or single function that we're seeing today. So with that kind of discrepancy between people knowing that they want to do it, but not really feeling fully prepared or fully understanding how they're going to do it, you know, we feel production optimization systems, or yield optimization systems, are a natural solution for dairy companies looking to implement AI with a clearer return on investment. Um, so when we say production optimization systems, what we're really talking about are systems that sit on top of your OT, or your operational technology, and your production management system layers, and focus on optimizing your production for specific outcomes. And generally, historically, they used to run more on, restrictive algorithms, kind of if this, then that logic. And nowadays, with kind of the explosion of data, what they've moved towards working on top of, or implementing, are what's called machine learning, or ML models. So machine learning, for those of you, is really, it's a segment of artificial intelligence, kind of as mentioned earlier, but it's great at predicting things that will occur based off of patterns that models have seen in the data. Right. So it's using examples to tell you what's going to happen, not rules. And that allows it to extrapolate and solve for previously unseen scenarios, whereas, more traditional rules engines or restrictive algorithms would, if it hasn't seen the scenario before, not provide any output, right? And on top of that, the systems themselves tend to improve with more data, right? So the more patterns that it can build, the deeper the patterns that it can build, the better it's going to be at providing realistic predictions of what will actually occur. And, when we talk machine learning, you may hear or have heard words around the types of models that you're implementing: supervised learning, unsupervised learning, and reinforcement learning. For those of you that don't know, kind of supervised learning is generally what we're seeing, the types of models that we're implementing. But the idea there is that, it's a labeled outcome that you want to train the model to understand, and that's kind of the supervision around it. Unsupervised, on the other hand, is all the data is pretty much anonymous, it's unlabeled, and it's up to the model to group things together. And this is more kind of like customer segmentation, right? Where you want to group your customers into specific groups, although you may not upfront know exactly what those groups would be. And the last one is reinforcement learning, which we're starting to see, but this is more traditional. I like to use the example of anytime you've watched a video of like AI beating a level in Super Mario, that is reinforcement learning. Essentially, you're just training it to understand what a reward is at the end of whatever you're trying to do, and rewarding it when it gets closer to that reward as opposed to when it doesn't. So the areas of production that we're seeing these systems implemented in, it's kind of two main parts, right? We're seeing them either optimized for specific outcomes, and so in the cheese space, that's final moisture, fat, salt, pH, kind of your more traditional identities for cheeses. And then on the other side of that too, we're also seeing process optimization. So during production itself, is there a way that we can optimize for energy usage around the vat, or just general time in the vat, or potentially uh, time on tables? So it's kind of the two halves of, can we optimize for the cheese itself, or can we also optimize for the production processes? And then we're also seeing kind of what you would call like a combination model, where you're optimizing for a particular outcome, but as a part of that, you're also trying to keep a particular part of the process within a constrained time. So um, ultimately, at the end of the day, the goal for these production optimization systems is to be as interoperable and equipment agnostic as possible, right? Your plants, or plants in general, are not a monolith. You have a lot of different technology providers, you have a lot of different equipment providers, you have a lot of different vendors. Being able to build models that use all of the data, not just compartmentalized on specific parts, or how you build models that are incredibly valuable. And so, keeping it one level above everything else kind of allows you to do that. So we get to probably, based on the second poll there, one of the more interesting slides in the entire conversation. But as I mentioned earlier, one half was ML, or one half of the AI areas we were talking about were machine learning, which are driving these production optimization systems. But the other incredibly important area right now is what's known as large language models. These are your Chat GPTs, your Claude, your Google Gemini, just your what's big in the news. And it's really not so much that these models are going to solve your production optimization questions. More so, the question is going to be, can these large language models help you build, production optimization technology or any other technology in your plants or in your organizations? And so what they're really great, I love Claude Code. I think it's one of the more powerful tools um, that have come out in a long time. You know, I still know what I want to develop, but at this point in time, I can tell it what to develop, and it writes code a lot faster than I do because it's a machine, which is great. So what's happened now that we have these large language models is, before, when you were making the build versus buy decision, and this is not specific around building production optimization systems, but just in general, is the questions were, can I build it? How do I know my engineers and my product teams got it right? And do I have clear business unit, BU, or product ownership around what we're building, right? Is it a vision? Do I have clear understanding of what it's going to be and who it's going to serve? And now that we have large language models that can effectively turn prompts into code and allow you to deploy that code and stand up an application in a week, half a week, an afternoon, now the questions go from, can I build it, to, can I support it? Once it's in production, do I know that if it breaks, that either me and the LLM or some of the engineers I have on staff, can we actually support what's been written and deployed? Can I tell when the model's wrong, right? The conversation goes from, can I articulate my thoughts around what we need to deliver clearly to can I understand after a model's interpreted what I said to know that all the logic is correct. All the functionality actually functions like it does, and I don't just get a yes, yes, it works at the end, right? And then do I have engineering ownership? When you go from engineers building something to, product managers or maybe one single engineer, really the question then becomes how do we transfer what's going from development and on a dev server to once it's deployed, do we make sure that it falls within the engineering governance model and do we actually have people who are ready and able to support it? But the one thing large language models haven't really changed around the build versus buy decision is can you clearly articulate the ROI of what you're building? Which I think functionally a lot of people miss in this whole AI conversation. It's really said, how do we accelerate what's being built? That was never really the bottleneck, in my opinion. Yes, you had to have engineers, but it's really is what I am building worth it? And so kind of what that two by two matrix, the build versus buy, kind of what, at least in my opinion, has flipped to is competitive advantage still stays on one side, right? We always wanted to build the things that we felt gave us a competitive advantage. But then, it went from ability to build it to ability to support it, right? Because now kind of the most important question is once it's launched and live, can we make sure that it stays working and we don't cripple our business by relying on a piece of technology we don't really understand how it was built. And so, high competitive advantage, low ability support. I mean, at least I feel personally that that's still a buy. But high competitive advantage, high ability support is definitely a build. Low competitive advantage, high ability support. I mean, I think that comes down to organizational decisions of build versus buy. I mean, you can almost get things out as quickly as you could buy them now previously by building them. So it's really comes down to that. And then low competitive advantage, low abilities to support is really, what that comes down to is these are things that we don't really need. So why not just offload it onto someone else's plate? And when I'm talking kind of ability support, it's really more about the risks of managing systems in production. And I'll keep this focused around, production optimization system, which I would have said, for most organizations, really, unless you have the data science expertise, the cheese making expertise, and then the engineering infrastructure expertise, you would struggle to support, or at least theoretically, right? It'd be tough for you to support it, even if you were able to build it. And the risks themselves kind of fall within two buckets, or at least that's how I feel. So the first bucket is kind of what we would call the model, right? Like our ability to provide these optimization recommendations. And it's really, unless you have the data science side of the house, it's tough to answer the problems of, what is the actual area of artificial intelligence I want to employ to solve this problem? What's the right model, right? Some models focus really heavily on categorical data, while some do better with just numbers. What features actually make sense to feed into the model, right? And that's, both your cheese making expertise and your data science expertise around, like what can we do? How do we get the right features in? How do we know that it's working once we're producing recommendations? Because it's not always as simple as, just looking at the numbers. I think you have to understand a lot of the metadata and the model's own confidence around how it's predicting. And then kind of the last question is the problem even a good candidate to solve with AI? And that may be the first question that you ask, but ultimately, with the help of data science and engineering, they can always generally point you in the right direction, whereas LLMs are a little uh, sycophantic and they will always help you solve the problem, right? And then on the other side, so that would just be, are even the recommendations we're getting or the way that we're optimizing, are we risking not understanding exactly what we're doing there? And then on the infrastructure side, you're still essentially building, what I would consider like a software as a service platform, or at least a enterprise application, right? And so they're not set it and forget it systems that once you vibe code something and deploy, I mean, these are critical pieces of your production infrastructure that are helping you drive the production of cheese, right? And so you need continuous monitoring. You need to continually retrain as your data kind of drifts seasonally. you need to do still classic, application and infrastructure monitoring to make sure that, you're even producing recommendations. And then there's a level of governance and testing around, who can deploy changes to models? How do we go about testing that the change is successful? Who manages or at least understands when it's acceptable to deploy? And so at the end of the day, kind of what we see is that, if you're building a production optimization system, it takes a pretty rare combination of cheese making expertise, data science, and then engineering, which generally large language models are great helpers, but without that expertise guiding it's tough to, build something that'll stand for long term. I mean, Eric, you were working in managing plants for a long time, looking at the risks here um, looking at the risks here, I mean, would any part of this particularly frighten you as far as managing a production optimization system you had built in-house?
Yeah, so having worked with the Cheese Yield Optimization team for the past 2 years, we've had a lot of learnings and improvements in process in managing data and how these systems are deployed. There are so many pitfalls and opportunities where items can be missed, what the model is doing in the background, that having a partner who has the experience in data science, has the experience in the dairy industry, really makes sense for delivering a solution like this.
Yeah. And I think a lot of what we've seen too are what I would call silent risks, right? Where you traditionally build an application and it either works or it doesn't. You get an error code when you try to hit submit and there's an issue. With a system like this, you could you could have mistrained the model on the latest deploy. It could be, everything could functionally look the same, but it could just be producing bad recommendations and you wouldn't know unless they were, egregious recommendations. But it would cost you money down the line once you had, once your cheese was either aged or once it had come off the line and sat in the storehouse. But ultimately, that is the real risk here that even when things do look right with these types of systems, they still can be particularly risky in cost. So now that I've sufficiently scared all of you into, what potentially the pitfalls of managing an application or a product like this, uh, I think Eric, you have a very good understanding. Kind of, you just mentioned what EverAg's approach to it looks like, but go ahead.
Yep. Thank you, Michael. So at the heart of it all, CYO, it's a partnership between Everag and the plant. We work beside you to make a plant-specific model. It's a model that's trained on your processes, your data, your expertise. I want to highlight specifically that CYO is a hardware agnostic product. We integrate with the data that you have, and so you're not just buying new equipment to get more value. And depending on where you are in your digital AI journey, we can also help you if you don't have digitized data, if you don't have make sheets that have easily available data. Everegg has solutions to be able to get you along on that journey. So what does a CYO application look like? We always start by visiting the plant. We walk the process. We talk with the people who actually make the cheese and make the plant function. We look to understand where decisions happen and where recommendations could be applied and to best help your process. Throughout a series of workshops, we will determine effective control points, targets, and data sources so that we can best supply recommendations for your specific cheese making process. Once those data sources and locations have been determined, the Everegg Data Labs team will go through your historical data and we'll start building an initial set of models. I just want to focus on that this is not a black box process. We review and rank key drivers that are helping determine what recommendations and what the outcomes for your models are. We share those insights throughout the development process. I like to describe this kind of like a game of 20 questions. If I want to predict moisture, what are the most impactful measures that I want to know first before I make a recommendation? So that as we view and track live production, how can we make better recommendations downstream? So once these models have been validated, they've been reviewed with the plant, we can turn to live production testing. In these live testing scenarios, we are surfacing recommendations at the point of use. This could be a scheduled recommendation that is surfaced daily to the operations manager or a cheesemaker, or this can be an in-process recommendation that is positioned right at the HMI. Given every single VAT, a new recommendation will come through, giving operators a consistent way to deploy these recommendations. So our goal is simple. It's make AI and recommendations easy to act on, to build confidence in hitting targets, and in the end of the day, give operations teams the confidence to be able to push their targets and improve their processes without increasing risk. Oop. Sorry, a little bit of a delay there in changing slides. So a little bit of background. When I was an operations manager previously before coming into EverAg, our goal weekly was to produce the highest yielding cheese while always making sure to maintain our customer specifications. We had a great team at always as meeting our targets, but sometimes you left a little bit of money left on the table. Maybe you had a low yielding VAT. Sometimes you overshot and you created some rework. Because of these types of problems, there are points where AI can be utilized to make recommendations on how downstream processes can be improved. I've always believed that using data should be the first choice into making better decisions. So when we were going through daily make sheets, we would look at last week's review, looking at dashboards, trends, but there is a limit to how much one team or one person can juggle all at once, especially when you're working in a live production environment. So looking back, if we had a tool like CYO, where we could have reacted faster to changes in milk, cultures, mate conditions, instead of reacting after the fact. And that's really what CYO is all about. It gives operations a way to evaluate far more data than any one person or one team ever could, and turn those into practical, usable decisions on the plant floor. I want to give a couple examples of how CYO is being applied to improve processes. Moisture control is probably the biggest lever most plants have to be able to improve their yield without changing headcount, without changing equipment. We talked about these inline recommendations where the model focuses on making downstream process changes post-transfer from the vats. So this is looking at controls around your DMCs, around your tables. These recommendations are kind of turning that fine-tuning knob of based on the conditions that happened in this vat, what were the outcomes of standardization? What materials were added to that vat? What was the cook temperature at the end of the day? All of those processes changed upstream can be responded to with a inline recommendation on every single vat. Because these recommendations are being supplied across all shifts, each team is utilizing the same logic. That same logic then reduces variances across shifts and allows targets to be improved because each vat is getting that fine-tuning knob to make sure that the final outcome of moisture is within that customer specification. We look a lot at recipe optimization. These are types of scheduled optimizations where recommendations are provided to the cheese maker ahead of time to align with the make plan for that day and to target specific customer specifications. These recommendations are targeting recipe parameters to be able to improve targets like moisture, targets like FTB, and these recommendations provided to the cheesemaker are at the discretion of the cheese plant. We're able to open up what features, what parameters are open to the model to be able to make recommendations upon. Daily, those recommendations come to the cheesemaker and have the opportunity to either accept or deny, and then push those down to the PLC to optimize that day's production run. pH control, as we know, cheese making, it's as much as an art as it is a science. We're dealing with live organisms that change. controlling pH downstream is a very effective means of moisture control and process control. So CYO can make recommendations around starter conditions to help teams produce a more reliable pH target. So we can monitor starter growth and outcome data to be able to make recommendations for time, temperature, and volume adjustments for direct vat set and for bulk culture growth. Because as variation goes down in your final pH, moisture becomes more predictable and the entire confidence in the system improves. These recommendations are planned at the start of the run, but they also are implemented and improved as the culture rotation continues to that run, making small tweaks and recommendations as the production run continues. Last example I want to share is just market optimization. We know the price of butter fat in the industry changes throughout the year. There's different times and opportunities where maybe selling more cream is a more optimal solution than producing additional cheese. So utilizing the expertise for the EverEgg Data Labs team, we can provide optimized recipe parameters to target FDB and what percentage of your butterfat production should be allocated towards cream versus being allocated toward cheese make. The goal of this is simple, to be able to make the best decision of where ingredient utilization should be made. Changes in FDB can have a very large effect on your final moisture. So that's where the CYO side of it becomes a great pairing. As your total standardization targets change, how should the recipes be modified to adjust it accordingly? And like we said, for most plants, moisture control is going to be definitely the most effective means for increasing yield and revenue. So I wanted to walk through an example of what is the measurable impact of applying a system like cheese yield optimization. So as an example, for a plant that produces 200 million pounds of cheese annually a year, CYO can help you reduce that standard deviation by 10 basis points. That'd be the equivalent of going from a standard deviation of moisture of 1.0 down to around a 0.9. This is through optimized recipe management and changes in the cheese make process. That small reduction in standard deviation gives cheesemakers a lot of room to be able to increase their moisture points. So by increasing their finished moisture target by 0.3 points of moisture, that is the equivalent of producing an additional 700, 800,000 pounds of cheese annually. At the current market rate of around $1.50, that's over $1 million in increased revenue from small adjustments across your cheese making process. And that savings opportunity is just focused around moisture, getting improvements around pH, getting improvements around ingredient usage. All of these improvements yield into more consistent grading, tighter customer specs for your customers, and just overall better, more predictable outcomes every day with additional savings. So what does a plant that's CYO ready look like? So we get a lot of the time, a lot of questions asked of just like, what do I need to be able to deploy CYO? The first and foremost, it's the amount of data that you have, the plant, it doesn't need to be perfect to get started. We can start by utilizing the data you have today, and we can help provide recommendations on what data and what possibly maybe even additional metering is needed in the future to be able to get the most out of a product like CYO. But in general, most plants who are CYO ready are going to have a significant production volume to be able to achieve the size of scale for improving in their cheese making process. Some of the key questions we'll look for is, do you have historical data for your plant? Do you have digitized make sheets? Are you still working on paper make sheets? Do you have well-mapped finished data for your in-process and finished results mapped back to the vat? All of these training points are going to be required to be able to train a model and build a repeatable set of recommendations. If your plant doesn't have these items, Everag has a suite of solutions that can help you reach those goals and be able to digitize your make sheets, add points of entry on the floor to be able to get those data points into the system. Lastly, it's looking at levers to pull. It's CYO is only as valuable as where you have points of opportunity to make those changes. If your plant already has points of operation that your production team is already using daily to respond to changes, those are great. Those are the key opportunities we look for on applying CYO of how models can be most useful. So if you're thinking of this, if you're thinking about this process and you think maybe we've got some of this, maybe not all of it, we want to have that conversation with you to make sure so we can help you bridge that gap on your digital journey into machine learning.
Yeah. A lot of what we see in the conversations are organizations are afraid because they feel they're too immature. And that's just generally not the case. I mean, you're there's not ever been a plant that we've been to that has not managed the cheese make process through some data available,
Yeah.
right? So it's really rare to see a plant that is in no position to implement this. So it's really important. You're probably doing better than you think you are, and it's always worth the conversation. And then on the production volume side too, obviously, right? We're talking a lot about marginal improvements, but realistically, if you just struggle to make consistent cheese, it's also a good application of that too, right? Where production volume doesn't matter so much there as you really just if you're looking for help standardizing and getting consistency in your recipes, it's really great for that too.
Well said, Michael. I think that brings us into our third poll here. So now that I know more about CYO, where do I think my organization could find the most value? Another even spread. It's great to see that people are looking into this and seeing where opportunities and values are available for their cheese production. So we know every plant is different, and what CYO may look like for one is going to be completely different for another. And with your process, your targets, it's all going to be different. But that's where CYO excels. It's a flexible product with opportunities for different sizes of cheese make. In this process, implementing AI, it's a journey. Um, we can let us help you utilize the data you have today so we can help you make better decisions for your data tomorrow. If you want to understand more what this could mean like for your plant specifically, please feel free to reach out to Michael or myself. If you have an Everag representative you work with, please contact them and we can make sure we get the right meeting scheduled.
Or if you're just interested in talking about this more, obviously Eric and I love it. We live it every day. So we're also just happy to sit down and talk for another hour with you.
Gentlemen, thank you for an informative webinar. And Michael, to your point, your enthusiasm and the degree to which you're embedded in and invested in what you're doing is evident. Definitely, we're going to tap into that expertise a little bit more with some of the questions. One more entreaty to the attendees. Down at the bottom of your screen, the little Q&A icon looks like a thought bubble with a question in the center of it. Click on that, use that to submit your questions. I did also receive one through the chat so far and noted, so we'll get to those as we progress through the remainder of the event. We've got about 15 minutes left, so happy to go ahead and get started. Guys, from the very first polling question, I think we saw about 40% of respondents are somewhere in the implementation process, whether they're actively implementing today or they have already implemented and are enjoying the benefits of AI. So conversely, that means that about 60% are not anywhere in this journey yet. How do you draw people into what can appear to be a very daunting process in terms of scale and scope?
Yeah, I mean, I think that's a good question. I mean, I think a lot of what gets thrown around with AI today is about possibility. But I think the first step is always validating a use case with ROI around it. So, with cheesy optimization here, I think the ROI is very clear, but that would be what, an organization I would encourage you to start with is don't necessarily think about what AI can do in the aggregate. Find a very specific problem that you can apply this to and has a very clear ROI. So, i.e. moisture control, helping with moisture control and pushing that to produce more cheese, right? Um, with the same inputs. I would push organizations to do that. And then also, a lot of people are afraid, if you're not going to go out and use like a commercially available product that's trained on, a global data set to do something kind of not vague, but like, handle not your organization specific processes or problems. A lot of people are concerned that like, well, I don't have data for it, or my data is not accessible, or it's not trained, we can't train on it. Generally, there's a good part of your data that is available, and you can start to build with that. And it may not be, you may not see 100% of the value you expected immediately, but you may be able to get to 80% of it. And then as you can build your own data set, as implementing this, and a lot of it comes down to building coherent data platforms in your organization that ensure quality and integrity of the data. As you build that out, which you naturally will because you'll want to expand the ROI on your use case, you'll see kind of your own journey into implementing AI further. And just as a part of that, you'll bring along kind of your own data maturity.
Yeah, as we discussed in prep for today's webinar, there's an incrementality to this, right? You really have the ability to start where someone already is on the journey for implementation and help to advance the ball forward from that point. So I think
Exactly.
that's
Yes.
a
Starting small and incrementing forward is, I'm a product person. I always live by the motto of let's build what's 20% that gets us 80% of the value, and then you keep going. And you can certainly take that same approach with these types of solutions.
It's definitely a walk to run approach. And the savings that come from maybe implementing your first model can then become, okay, now that'll drive the additional investment to getting a sensor around a downstream process to be able to deploy a model there. And it's kind of, we can incrementally work your way through and use the savings from one to drive savings on the next.
Yeah.
very good. If I can get the two of you to generalize a little bit, because I know the answer may vary from case to case, but talking
Mhm.
about that data and talking about readiness, how much data do you need? Are we talking about a year's worth of run data? Are we talking about 100,000 data points? What's really kind of that threshold before you're ready to start training a model?
It's
Um,
it's definitely a mix. We have
yeah.
seen models train well on as little as 6 months of data. We typically look for around a year of historical data, but these models we have gone back multiple years of training to be able to make recommendations.
Yeah. Generally, I think we're trying to capture seasonality. Um,
Ah,
but yeah, that's a good. And then structurally, it, having some type of um record by record structure, which you would consider um a structured data set that's focused by day by VAT, that will allow us to train our models more efficiently too.
Yeah, Michael touches on a good point there. The seasonal view around the data set
Mm.
is very impactful for the model. So we know producing cheese during the spring flush versus in the peak of winter, the milk composition or in summer are all going to be completely different. So giving the model the opportunity to see cheese make across all seasons and then train on that seasonality is very beneficial.
Yeah, certainly important. I hope that that's baked into any dairy professional's understanding of their own industry, but that seasonality dimension has to be a factor in your model training and validation. Let's
Mhm.
jump directly to validation. Then we had a question that got very pointed about how you assess when a model is good enough to be rolled out. Root mean square error, MAE, R squared, variance, correlation,
Yeah.
all of those things. How do you decide when it's ready to go?
Yeah. Um, I could talk. Eric, actually, I think it's better for Eric you take this because you can talk about how we take these
Yeah.
directly to the
So
cheesemaker, right, and make them feel comfortable with where the model's at.
Yeah, so we spend a lot of time with the our exceptional data science team here at Everag. I can definitely speak to this as a layman of data science and as more of a cheesemaker background. But as we train these models, using tools like RMSE are a key focus in how available and how ready the model is to be deployed. So we use that as a benchmark over time to be able to see, okay, initial set of training, where did we lie? Okay, we've made optimization changes. We've done cleaning to the data. We've been able to prune the model down to its optimal set of key features. That is a key part of the model development process that we keep the plant involved in as these models progress. Week over week, as models improve, we share those reports with the plant, and then when we
Mm.
determine that the improvements that are being made are sufficient enough to be deployed, we will let the customer know and then start moving into in-process testing.
Yeah. Yeah, and we look a lot at the background variability of the recipes at the facility too. That's generally our baseline, and then we also, I mean, Eric's been in this industry for so long, he's able to give us, some heuristics around how we think the model should perform, and we use those essentially as guidelines and to help with the conversations with the cheesemake team.
Yeah, so data scientists are not cheesemakers. Cheesemakers are not data scientists. So being able to combine Everag's dairy experience and knowledge combined with the data labs team exceptional abilities on their end, it's a very good match and pair.
Mhm.
Hence that deliberate intersection between Eric, your background and experience, and Michael, his unique skills as well. So points very well taken. Um,
Mhm.
so talking about where dairy is on that data quality and quantity journey, maybe comment on dairy at large from your perspectives, and then because this is cheese focused today, where are cheesemakers in this journey to collect and clean and make data ready for AI application?
I think in the AI space that we're in, the adoption rate is just excelling in terms of um, individuals having access to these large language models, having tools that we've never been had access before. And I would say 2 years ago, the sentiment that you would get talking to a cheesemaker is this tool is here to replace me. This is you're trying to not you're trying to not you're not saying you don't need me, but that's definitely not the case. As cheesemakers are required in this process, and the adoption rate and the ability to utilize models to make better decisions and the confidence in those models to be able to make these recommendations. I think the overall view has changed so much in the last 2 years, and we see it with customers that we speak to every day.
Yeah. Yeah, I think in the industry as a whole, what you had for a long time were what I would call like the big rocks people had implemented, where
Mm.
it was the standalone MESs, ERPs, supply chain transport optimization or transport management systems. But at least, and I'll talk more specifically to what I'm seeing at Everag, but because we, provide a host of solutions that essentially run the gamut of the dairy supply chain, we're at least seeing a greater appetite for integration and essentially normalization of data across those. And so that is really being driven by organizations wanting to use that like cross functional data to drive these types of optimization solutions. So,
I was curious if you're seeing, if you have enough insight to know if quality management systems are starting to incorporate elements that ensure that you have quality data for future applications in AI, as well as supporting what you have already committed to do.
are you talking about quality management in terms of like lab results of the cheese floor, or quality management as far as like um, systems that would look at the data you have, ensure quality integrity? Um, which one?
I think both of those things. You sort of tickled my experience when you talked about the plan, do, check, act cycle, which is
Hmm.
a foundational principle in continuous improvement and quality management. So I just wondered
Hmm.
the extent to which you're seeing organizations then make systematic commitments to ensure high quality data so that AI
Um,
transitions, new models, new problem solving is easier going forward.
yeah, okay, I see what you're saying. I'm sorry.
Oh, no worries.
Really, yes. I mean, yes. I think all the organizations we are talking with, a lot of what we do are data audits as a part of it, and so we have these types of conversations up front with them. But then, we have our own quality checks internally that we can
Mm.
flag when data looks bad or misaligned, and all of the organizations are incredibly reactive to fixing that. So. Um, I mean, I can't speak for the organizations themselves, but just based on our interactions, I would say they're all, at least everybody we're working with to implement something like this or implementing this, they are all incredibly understanding of what quality data means to these solutions and reactive to fixing upstream problems.
Got it. Good answer. Sorry to throw you a little bit of a curveball there. We
Yeah.
have time maybe for one more question, depending on how much substance this draws out. Um, you went to great lengths to stress the goal for Everag to achieve interoperability and to be brand agnostic. To flip that around, I'm wondering if for big processors that have multiple plants, is there an opportunity to discover specific equipment brand related areas for improvement where maybe they have horizontal vats in one plant versus conventional vats in another plant, or plant A operates, brand X versus brand Y versus brand Z. Is that an area where you can help to also tease out those areas for improvement?
I would say knowing the equipment differences, we would never suggest to, oh, we should train how plant A operates based on plant B's data.
Mm,
Each plant and each model is bespoke in its own training and its own design.
okay.
There are definitely trends to be had and opportunities that come from optimizations around a horizontal cheese vat versus a double O. Our models will help you better understand responses and changes to variables like changing temperature, changing of time at each of your unique plants. But the models themselves can be applied across a network of plants to be able to provide unique insights for each of those designs.
Yeah. Um, It it is so yeah, to Eric's point, every cheese line is unique, right? And will have a specific model around it. And then, I mean, if you are engaging us and we're looking at multiple plants, we also can still show you what performance looks like across those plants and across those lines. And so you could take a look at the trend lines and see, yeah, this recipe, assuming it's, the same recipe that you're running at other plants, you could see the differences and, the trends of the deviation from target over time. And we would be able to have a conversation about that. But yeah, to Eric's point, the models themselves would probably not be a good place to start around predicting cross line or cross plant.
Got it. Thank you very much.
No
Well, it
worries.
looks like we're right at time, and Beth is appearing to usher us out. So thanks, gentlemen, for your expertise and to the attendees.
Thank you
Yeah,
for having us tonight.
Thank you very much.
Thank you. As we wrap up today, again, I'd like to thank EverAg for their sponsorship of today's event, and Michael and Eric, obviously, for being with us today and sharing their knowledge and insights. One last note, Eric and Michael's email addresses are on the screen, so take note of those. And then as we close out today, ADPI thanks you for taking the time out of your busy schedules to join us and encourages you to watch for more EverAg webinars with ADPI that are coming in the following months. Thanks, and have a great day.
Thank you, everyone.
Thanks.